Thanks for joining us this morning. We really appreciate everybody getting up bright and early and making it in. Welcome to the second day of spring. Some days in Dallas you never know. Believe me, you don't like the weather this morning. It's too cool. Tomorrow it'll be warmer, okay, or colder, whichever. But we really appreciate you coming. Chapman Hicks is delighted to have the Aspire events and be able to schedule these. You will notice as you've been trying to sign up that we are filling out our events. We're trying to cut it off, and we're not asking anybody to sit in your lap yet or anything, but we do want we have standing room only. So please sign up early and make sure. We'll try and keep having really interesting topics and things that we think are very relevant to what you might want to hear about today. We also want to just remind you that if we can help you, your clients, anyone you're working with, customers, whatever, we are always looking for new clients, whether it's just compliance and tax planning, financial reporting, audits, or even over on the corporate finance side with our investment banking group. We have folks from tax, believe it or not, in spite of the fact it's busy season, we got them out of bed, and some of them just stay in the office this time of the year round, but there's tax folks here, investment banking people here, so if you've got something, you got a question this morning, we'd be glad to chat with you about that. Firm's been around, for those of you who don't know us really well, 28 years, and so during that time we've had a chance to work on a lot of things and do a lot of fun stuff. A couple of different things that we're going to do this morning. First, one of the things that we've started trying to do this year, we're kicking it off, is actually introducing a nonprofit to you for a minute to talk. Barbara, you want to step up and join me? I had the privilege this morning of introducing Barbara to you. We met Barbara years ago as our kids were going through St. Mark's. She's the executive director of a nonprofit here in Dallas called Hope Supply. My wife Kim and I are very involved, and Kim actually sits on the board. I think Barbara sees Kim probably more than I do, a lot of times. And but we wanted you to hear a few minutes about what's going on, what they're doing, how you can get involved. We're always looking for people who would like to be involved, who'd like to write a check. We're always looking for money. Did you hear me? We're always looking for money, okay? We're always looking for people who have a passion for being able to do this. One of the things that Kim and I are big on is that it distresses us highly that 20% of the children in this city don't have the things like food and diapers and things, the basic necessities that it takes to live every day, okay? And to me, when I look at this group and look at what goes on in the world that I operate in every day, we all live in a bubble compared to what the rest of the city operates in. And so trying to share that, trying to work, trying to find solutions and stuff, that's part of the reason we're involved with Hope Supply. So I'm gonna let Barbara do a quick infomercial, and I think there's a little bit of a handout there and stuff for you this morning.
Thank you so much. Greg is an awesome guy. He walks the talk, let me tell you. So great guy to be associated with. Thank you so much. And his wife, Kim, who's a superstar, is on my board. And that's been wonderful. And so Hope Supply Company, I put a bookmark on our desk there so you don't have to walk around with a flyer. You can put that in whatever book you're reading. And we've been around for 28 years, I guess as long as your company has been around. And you've probably never heard of us, which is why I'm here, to tell you that we're here. We're really a behind-the-scenes nonprofit. We used to be called Captain Hope's Kids, so you may have heard of us. I started about 3 years ago, and we did a rebrand. I think Hope Supply Company really speaks a little bit better to what we do. We're really a supply company for hope, kind of play on words there. We have a warehouse over here in West Dallas, and we are the largest diaper bank and supplier of critical items for homeless and at-risk children in Texas. So we have, would love all of you to come visit our warehouse. It's really pretty cool. You will see the other side of Dallas when you see what we provide to over 60 homeless services organizations. Some of them are homeless shelters, some of them are domestic violence. We've got drug rehab centers, anywhere where there are children living homeless. And right after this, I'm going down to the State of the Homelessness address for Dallas, and I will learn the new statistics on homelessness, which are always shocking. But there is a different world. Your thing about the bubble, yes, we all live in a bubble, and it's really, my job is so wonderful because I get to live comfortably, but also be involved every single day with those that are less fortunate. And just really quickly, I don't want to go on, I could go on for 2 hours, but just so you'll know, there are 3,500 students just in DISD that are homeless. 3,500 students this year are homeless. And homeless is just, the definition of that is not standing on the street corner with a sign, but living in a shelter, couch surfing, living with grandma because they got kicked out of the home. So just keep that number in mind. Those are the kids that we're serving. Our mission is children ages 0 to 18. So we provide diapers and hygiene and clothes and toys around the holidays and just anything they need all year. We are completely privately funded. We have no government funding. We pick up a lot of the slack that government should be doing. All nonprofits do. So we really need support. So please keep us in mind, look us up, have your little bookmark there to find us on the web, and please come visit us and get your company involved.
And one other number, how many diapers do you guys push out on average?
We, in 2017, we're just finalizing our numbers, we did 40,000 diapers a week. So we are members, we are in the National Diaper Bank Network, which is based in New Haven. And Kimberly Clark is behind that nonprofit, and we're one of their largest diaper banks, and we purchase diapers at bulk. So if you give us $1, it translates to about $8 of purchasing power. So it's a very important mission that a lot of you probably just aren't aware of, all the homelessness and also the diaper need and need for just all sorts of critical items that these kids just cannot afford. Lastly, last week was spring break. You were talking about spring. We also, other than providing the items, like that's our closet program, we do provide some very high quality activities for these kids who are at shelters, and we just hosted 60 kids at our spring break camp last week so that they can get out of the shelters and they too can go do something fun at spring break. So very high quality events and very high quality items that we push out. We don't do anything used, all brand new things that you and I would want to give to our own kids. So thank you for listening. Thank you, Greg. And please call me, get hold of me, Barbara at hopesupplyco.org.
Thank you. Appreciate it.
Thank you so much.
The other comment I would make is that, and people don't really think about this a lot, but there's really 3 major kind of diaper banks in the U.S., one out in California, one here with Hope Supply, and one up on the East Coast. And I know that when Harvey hit, for instance, you guys got slammed. I mean, there were millions of diapers moving at that point.
We were very, very involved in the Hurricane Harvey relief. I didn't think it would get up, I didn't think we'd be involved, but we were very heavily involved in that relief effort for several months. It really kind of slammed us. We got lots of donations, and we're sort of the logistics group that was getting it down to the coast. So that was a really wonderful experience for us, and just working on a white paper right now on how to deal with future disasters, because people look to us, Hope Supply Company, for those types of things too. So
thank you again.
It's great work. Thank you.
Thank you. A couple of other things. If you want CPE today, you can certainly fill out the form during the evaluation form. We'll get that certificate and stuff back to you. We also have a speaker evaluation form, and also I would encourage you on there, if there are topics, that's where we put things like the Bitcoin blockchain topic and stuff. We're consistently looking for things that I would say are new and interesting topics that affect financial people that really don't have things to do with kind of more the basic tax accounting type things, but don't have the new relevant things. So please let us know if there's something you think we should be looking at. Also, for those of you who don't know, we video, as you can see this morning, a lot of these different events, and they are in a video vault and stuff on our website. We break them down into segments, so you don't have to listen to the whole thing at one time. You can listen to 15, 20-minute pieces of it. But please make those available to other people. If you want copies, you want something to put out to people, or handouts or something from today, let us know. Same with other prior events. If there's something that you're interested in having, let us know. We'll make sure you get a copy in your hands. Well, it's my pleasure today to introduce Alex Treece. Alex is a lecturer at UT Dallas. He also helps lead UTD's blockchain initiative. What they're doing is a cross-campus collaboration to grow the blockchain distributed ledger technology, or DLT ecosystem. Additionally, he's a director of the professional program in finance within UTD's Jindal School of Management. And then the basically program in finance places UTD's top business students into investment banking, private equity, consulting, hedge funds, corporate finance, and other top tier roles. We do a lot of recruiting on campus there and have been very, very pleased with the students and the knowledge and information we get. This morning, Alex is going to talk about blockchain from Bitcoin to the enterprise. We thought this would be something you guys would enjoy. You should have your head spinning by the time he gets through talking to you, or either have nightmares, one of the two. Okay? So thank you for coming.
Yeah,
appreciate
absolutely.
it.
Thanks, Greg. Hopefully neither of those outcomes, but everybody, thanks for having me. Thank you, Greg. Thanks, Calvin, for the invite, and Chapman Hex. Happy to be here and excited that there's so much interest on this topic, especially outside the markets, which can be pretty volatile up and down. So obviously today we're going to talk about blockchain, sort of the underlying technology that runs Bitcoin, and sort of this emerging technology that we're starting to see across multiple industries. And this talk is really focusing on the fundamentals. There's a lot of different directions we can go, talking about crypto assets, talking about blockchain. In my experience, these things tend to focus on just use cases, and then you miss out on a lot of fundamental understanding. And so that's what I'm going to try to backfill here today and try to explain kind of the basics, if you will. So that's my goal with this talk and this discussion is to try to give you a more fundamental understanding of what blockchain actually is. And you can see the agenda here. I think we'll have some Q&A at the end, and hope you can ask questions that you're interested in. But to start things off, we have to talk about Bitcoin. And some of you may be saying, "Oh gosh, Bitcoin! I thought this was about blockchain," and it is. But any sort of rational discussion about blockchain really needs to start with Bitcoin because it was the first implementation of blockchain and can tell us a lot about what it was really designed for. Bitcoin originated back in 2008 by a person named Satoshi Nakamoto, an anonymous person who we still don't know who that is or if it's multiple people, and released a white paper in 2009, which eventually became the Bitcoin network. And this sort of quote here is actually from the white paper. It's the first line in the abstract. I think it tells you a lot about the intended use case for the original blockchain. So purely peer-to-peer, right, person-to-person, a version of electronic cash that makes online payments without going through the burdens of a financial institution. So right then and there, you already know that this was a technology designed to facilitate sort of peer-to-peer transactions and eliminate some type of intermediary infrastructure. And that's what we're seeing. That's both in the financial context and elsewhere. So Bitcoin is important not just because it was the first one, but because it ushered in some pretty interesting innovations. The first one of which was solving this double spend problem, which was an issue that required essentially to create electronic cash. And the issue was that like any file on your computer where you can just sort of copy it and paste it somewhere else, it's difficult to not have electronic data replicated. So they used cryptography and this first implementation of blockchain to solve this double spending problem, which was the first time it had really been done. The second thing, which I think is sort of a chronically underappreciated aspect of Bitcoin, is that it was something that was designed to be native for the internet, which means it inherited a lot of the internet's qualities of openness that are very attractive, I think, and it has it has a lot of use cases for that purpose. So it's very digitally forward. The other thing is it created a form of value that didn't require control by a central intermediary or authority. So it wasn't created by a government, it wasn't regulated by the Federal Reserve. It has an automated monetary supply. And so it brought these sort of decentralized characteristics that we really hadn't seen before, and sort of enabled some of these new technologies and use cases that we're starting to see. And then first and finally, it was the first implementation of the blockchain. So it's what really sparked this whole type of architecture that we're going to talk about called the blockchain. And so for that reason, it's very important. It did that by sort of combining multiple things together, cryptography, and something called a consensus mechanism, which we'll talk about, which helps manage a distributed database where there's lots of copies and you have to figure out, which one is sort of the correct one, what is the current state of the database. Here's some recommended reading on Bitcoin, so we're not going to talk much about it. This is not going to cover a lot of technical details, but it talks a little bit about the history of Bitcoin. It can give you some early insights into the motivations of the early players. I personally think it's pretty helpful to understand the ecosystem and give you some better appreciation by digital gold, by David Popper. But we're going to talk about, of course, blockchain, which is the underlying technology of Bitcoin, and more broadly, distributed ledger technology, which is sort of the more generic term, and again, focusing on foundational knowledge. So if there's one thing I want you to take away from this entire conversation, it's probably this slide. I think there's a lot of confusion around blockchain, and tend to be obscure, but it's actually quite simple. Blockchain is simply it's a technical architecture for storing data, period. And it's secured by math, something called cryptography, and it's a distributed database, right? When you hear the word blockchain, I want you to think about a distributed database that is used to store information. And to understand that further, you really need to understand the current way things work in the world. Most technology runs on something called a client-server model. So for example, if I send a tweet, send an email, use my credit card, there's some centralized intermediary, maybe Visa, maybe Twitter, that has this database, and I send a transaction, and it writes to the database, and it gets updated, right? Pretty simple. Most of the applications you use, and a client here is simply the thing that you use to interact with the internet, right? Your phone, your computer. And this is how most applications on the internet are structured in this way. And as you can see, there's sort of a centralized server that usually manages this, and sometimes it's multiple servers, but oftentimes it's pretty condensed, right? And that server, that centralized intermediary, manages the database. And there's a good reason that most of the internet is structured this way. So some of the pros are that it's a highly scalable architecture, right? When you can sort of pull the servers together, you can make it so that you can do an enormous number of transactions, and you can do them fairly cost effectively. And so that's the reason that Visa, Google, and others have used this infrastructure, because it facilitates a low cost per transaction and a very high transaction throughput, which as consumers would like generally. It also allows you to pretty tightly control the privacy and security when you've done it correctly. We know from experience, Equifax et al., that that's pretty tough to do. So that brings us to some of the trade-offs of this model. One being that it creates these honeypots, these data pools where you have enormous amounts of financial or personal or whatever other valuable information that is stored in a relatively centralized way, and that becomes a security risk pretty quickly. So it makes it easier to censor and attack, and creates pretty strong economic incentives to attack them. And it also means that they're not often that transparent, right? Because they have to sort of put these walls around these databases to protect them. And then that also can mean that they don't necessarily talk to each other as well, which can be a hindrance sometimes. The blockchain model, the distributed ledger model, is different because every single participant in the network stores a copy of the database, right? So the client-server model, what's listed at the bottom, you send information to a centralized database, it changes it, manages it for you, and you can sort of read the information back. In the blockchain model, every single participant has a copy, right? Which is interesting because that means that when there's a change made, it needs to get replicated on all the other databases. And this is really hard, which is what we'll talk about further. But the way that Bitcoin, for example, and other distributed ledgers have solved this problem is pretty interesting. And as you can see, there's some trade-offs to this model, but and we'll talk about this here. The biggest kind of pro to this model is that it doesn't require that central intermediary that you needed before to work, which is pretty attractive, right? I think in Bitcoin's use case, right, where it's sort of digital money, it's useful because you're not having to deal with a central intermediary in the form of the government, business necessarily. There's also pretty big implications in the enterprise world as well. We'll talk about some use cases later. It's also highly redundant. And it's hard to censor. So when you have a copy of a database stored on thousands of computers, tens of thousands, maybe millions in the future, that is, if you're wanting to censor or attack some part of it, that's really, really tough to do. So they tend to be have pretty strong strength in that regard. They're usually pretty easily transparent, mostly because early versions of blockchain were public. And they enable some interesting self-custodial business models. That I think is going to end up being one of the really interesting use cases where, before we trust our assets, we trust our identity to these different services, and blockchain is going to enable us to have self-custody of those things while still having a high level of security. Some of the trade-offs, and these are big ones, are that it's less scalable than centralized models. Again, when you're having to store a copy of a database on every single participant in the network, and you're having to come to agreement on every time it changes with all these participants, that is a very costly and hard thing to do. And that makes blockchain sort of inherently less scalable than a centralized infrastructure, which, and just to give you some actual numbers, Visa's peak transaction levels are something like 4,000 per second. So like on the busiest days of the year, Visa will process 4,000 transactions per second. For the Ethereum blockchain, which is one of the most popular development platforms of blockchains, it's something like 15 transactions per second. So obviously in that context, it's difficult to make Visa work on blockchain right now. But there's, we'll talk about those considerations, but this is one kind of big trade-off. The other one is just high cost per transaction, which is a function of it being sort of less scalable. They are less private, typically, and we're starting to see these permission ledgers that are more private, but the first implementations of blockchain were not private, and so and they're also immutable. So every time you put something in a database on a blockchain, it's sort of out there, right? And you can't stop it from being out there. That's both a feature, but potentially a risk, depending on the type of application. And then finally, I just want to mention that these require governance, and as we know from democracy, and we know from other areas of life, governance is extremely difficult to do. Anytime you have to have more than one person or multiple people deciding on something, it's hard, and so it's hard to blockchain. Here's an example of the blockchain application. Again, we're using Bitcoin just because it's easily the most simple to explain. And this is a sort of oversimplification, but Bitcoin uses blockchain for its database, for its network, as we mentioned previously. The data that's being stored is transaction data. So Bob sends Sally X data like that. It's public, meaning it's permissionless. Anyone can write to it. You don't need permission from Uncle Sam. You don't need permission from your bank. You can go send, you've got $100 billion of Bitcoin, you can go send it 5 minutes from now to anybody in the world. And this particular blockchain architecture is literally just a line of blocks. So there's transactions that are stored in these blocks, and they reference each other. And this will be stored on every single computer in the network. So that's the way that this works. Blockchain is a subset of distributed ledger technology, and as this technology improves, you're going to start hearing more about distributed ledgers and less about blockchain, probably. I think blockchain has sort of become a generic term, if you will, but it's technically different. And so I made a slide to sort of articulate that difference. So a blockchain is a type of distributed ledger. A distributed ledger is a type of database, right? And so, using a car analogy here, a Toyota Corolla is a type of car, which is a type of transportation. Very similar relationship. So when you hear blockchain, think it's a type of distributed ledger. There's other types as well that aren't blockchains. In fact, IOTA, Hashgraph, a lot of other technologies are coming out, and they don't have blockchains at all. It's something completely different, but it is a distributed ledger. So they're trying to get some of those similar qualities that you can get in a blockchain without some of the scalability issues. And they typically require something called a consensus mechanism, which is being used to get everyone to agree on what the state of the ledger is, right? This problem arises again. You've got a distributed network, there's lots of copies. How do we agree what all the copies say? And if Sally sends, X to Bob, we need to make sure that everyone sort of reflects that. And so consensus is hard. And it often has many participants versus private permission ledgers tend to be more like a traditional database and have less. And these are typically where you see the native tokens. So Bitcoin, Ether, Zcash, Monero, all these tokens that are highly volatile, and you hear about in the press. Those are tokens usually running on public networks, and they're used for a whole bunch of different things, but typically for some type of economic alignment is what they're supposed to be used for. There's also private distributed ledgers, which is kind of more. If we're talking about enterprise applications, this is more where you're starting to see the development. And unlike a public ledger, it's closed, and it sort of looks more like a traditional database in that sense. What they're trying to do with private ledgers is get some of the qualities of a distributed ledger without having all the scalability drawbacks. So it's sort of like an in-between. Thinking about blockchains here and a traditional database here, a private ledger is sort of somewhere in that spectrum in between. You generally trust the participants in a private ledger. You may not completely trust them, but for example, R3 Corridor, which we'll talk about a little bit later, they've got a financial blockchain, and they have banks who are the nodes in the network. They're the participants in the network. They're the ones who are confirming transactions. And so you generally, if you're JP Morgan, right, you don't completely trust Goldman Sachs, but you generally trust that Goldman Sachs is going to act in their best interest and sort of act in the best interest of the network. versus something like blockchain or Ethereum, which is completely public, and it's like anyone can use it, and it's like who knows what their motives are. So it's just a slightly different situation there. So there's typically fewer participants because of that. And they can have a native token, but it's not really necessary, right? Because you're not having to align economic incentives as much for consensus because you have fewer participants. So you don't typically see tokens on native networks. And some examples: Ripple, Hyperledger, or Treece Corda, which is one I just mentioned a second ago. JP Morgan has one called Forum. In its Swirl, which is a hash graph technology, which is actually going to be at a conference in April. Are some of the examples. If I, here on the public, or if I miss your favorite blockchain technology, I apologize. There's a lot of them, and I'm just trying to get some of the top ones. We talked a little bit about consensus mechanisms. This is the mechanism that it was sort of pioneered by Bitcoin. It's now being used in other blockchains and distributed ledger technologies to figure out. So we've got this distributed ledger, right, that holds this data on all these different places. Now we have to figure out, okay, how do we get all these different ledgers and all these different places to agree with each other? And as I mentioned, that's a hard problem, and consensus mechanisms are the way that you solve that, or one way to solve that problem. In the most and much easier to do in a private network, right? If you think about the client-server model, like a traditional database where there's one database, your consensus mechanism is one person just decides it's in the database. That's super easy. Then when you get to 2, it's still pretty easy, but when you get to like 1,000 or 1,000,000, it's really tough. Proof of work is kind of the prominent consensus mechanism for public ledgers right now. That's what Bitcoin uses, that's what Ethereum uses right now. It's what creates this thing called mining that a lot of you have probably heard of, where you have this computationally intensive energy requirement. And the purpose of that is, in a nutshell, is to create this cost to each transaction. And it's a way to secure the network and to come to consensus. There's an alternative model. There's many alternative models. One popular one is called proof of stake. The only difference between proof of stake and proof of work is that instead of, in a proof of work system, we're using computer and energy to confirm transactions. You're staking capital in a proof of stake system. So you sort of do away with this whole concept of like using energy. It has sort of a different type of cost altogether. There's a lot of people who say, oh, proof of stake is better because it doesn't waste as much energy, yada yada. That's technically true, but there's sort of economic trade-offs for these models. One, for example, in proof of stake is that you have the opportunity to become more centralized more easily in some cases, right? Because if you just have people that have a lot of the tokens, they can stake them and they get more comfortable with staking and sort of this cycle. I think the jury's still out on the best consensus mechanism, and we'll see kind of over the years what ends up happening. I think proof of work is extremely stable, extremely proven, has pretty clear drawbacks in energy consumption, and I think also some location arbitrage with different areas that have better pricing on energy. For example, you're going to see more centralization there. And in a point I kind of failed to mention I should now is that in these distributed networks, centralization is kind of like the enemy. It's what you don't want. And so anytime that you have kind of more people, at least in a public network, or even in a private network as well, anytime you have more people that have more control of the database, you're getting closer to that traditional database structure, right? And it's like, if you're going to do that, just use a traditional database. Tokens. Again, these are what you hear in the news. This is Bitcoin, Ether, all the other ones. The extremely volatile asset class, emerging asset class. What you would buy if you went to go buy Bitcoin on an exchange. I have to say Bitcoin, big B is the protocol, Bitcoin little b is the token. And really, a token is just an arbitrary piece of data that you own. So again, I mentioned earlier that blockchain enables this sort of interesting self-custody ownership model. Well, tokens are a pretty good example of that, right? I can sort of own this arbitrary piece of data that can't be copied or replicated anywhere. And currency is just sort of a really natural and interesting application of that. But really, it can be anything. In fact, there's a whole class of tokens emerging called non-fungible tokens, which are not things like currencies, but are things like identities and just arbitrary assets that have metadata. And so that's like kind of a whole emerging field. We'll talk a little bit about it. But I think the key point here is that these aren't required for distributed ledgers, right? I think they're used pretty often in a public ledger because they're useful for consensus and for Ethereum's use case, they're used to pay transaction fees on the network. Actually, for both Bitcoin and Ethereum. So they're not required for all distributed ledgers. For example, Hyperledger doesn't have a token, which is a technology we talked about. But they're most often used for economic incentive, governance, or utility. To trade this token for this service. Great, and I want to cover just some specific protocols. We've talked about some of them already. Again, I apologize if I missed your favorite protocol on blockchain. For time's sake, I wanted to focus on just a couple of ones. I know there's a lot of text here, but we'll try to cover this in detail. The first one is Ethereum, which is a public blockchain. It's one I'm actually most familiar with. And it's a general purpose computation platform that uses something called smart contracts. And that's a lot of fancy kind of language, but really what it means is that it allows you to build any type of application on it, right? It's sort of a replacement for internet infrastructure. It's an alternative type of database for the internet, is one way to think about it. It has a consensus mechanism for work, as we mentioned. It's switching proof of stake in 2019 in order to become more scalable. Its peak transactions per second is 15. Like I mentioned earlier, that's really low compared to something like Visa, which is really high at like 4,000. And actually, I think Visa can scale up to something like 56,000 transactions per second if they wanted to. They don't get anywhere near that. So obviously, scalability is an issue here. The most common use cases to date have been for fundraising. I'm sure you guys have heard of like mutual coin offerings, ICOs. Most of those are put on the Ethereum network. It's very good for that, obviously. I think you'll see it expand on those use cases. I'm pretty involved in the ecosystem, and I can just say that there's a tremendous number of general purpose applications happening in every type of field and thing you can imagine, supply chain, business applications. So I think you'll see it start to move away from ICOs over time. In my opinion, the key opportunities for Ethereum for that, it could become the key internet infrastructure for Web 3.0. So if sort of more of the internet moves towards this distributed database model, Ethereum is in a pretty good position, assuming it can improve its scalability. They also have a model where it's pretty easy to do a private version of Ethereum and like hook it up to a public version. In fact, JP Morgan Forum, which is one of the permission ledgers I talked about, is actually a fork of Ethereum. So they just sort of took Ethereum, they made it private, and they solved this issue of like anyone being able to use it, but it's still Ethereum. It can sort of play nice with it. So I think that's an opportunity. And Ethereum is by far the largest development platform. It's sort of the most prominent platform for getting actual applications done. So I think it has a chance right now to become the de facto protocol, if you will. But we'll see. I mean, it's kind of impossible to predict, but it certainly has the most momentum. The weaknesses are that the transaction throughput is low, as we've discussed multiple times, and the costs are very high. There's been several times where the network has sort of come to a halt because of this transaction scalability issue. And right now, there's not really adequate privacy for enterprise application. They're working on that. I think they'll solve it. But right now, obviously, you're paying a bunch of sensitive data. You probably wouldn't use Ethereum. And then lastly, I think it just has a somewhat legacy architecture compared to some of these new protocols who may not even be on blockchain at all. But Ethereum is definitely one to keep an eye out for. They have this Enterprise Ethereum Alliance with a tremendous number of enterprises signed up to it. And so there's a lot of people doing proof of concepts. The other one is Hyperledger, which I think is probably the other most notable one for enterprise use, and it's a highly modular kind of operating system, if you will, for distributed ledgers. It doesn't have a token. It's highly supported by IBM. It's a collaboration really between the Linux Foundation and IBM, and it doesn't necessarily need a consensus mechanism because it's not public. And you can put one on there for your specific application. It has very high transactions per second. As you can see, 3,500. That's getting pretty close to Visa's peak 4,000. And this was definitely designed to do this way because they knew that enterprises are going to want to have high transaction throughput and low cost. I tend to see it used in pretty much all these are proof of concept stage. I should mention that, but I tend to see it used a lot in supply chain applications or anywhere where you're transferring sensitive data. And you're wanting to set up you're going to either eliminate an intermediary or wanting to sort of set up a shared database between multiple companies, and I think supply chain is a pretty good example of that. So you see it in healthcare quite a bit. So there's a tremendous amount of momentum behind Hyperledger as well. And I think that the big opportunity for Hyperledger is that it has a chance to become like really the like an enterprise application. We'll see. Again, impossible to predict, but they're certainly positioned that way right now. It has the largest developer pool and adoption behind Ethereum probably. So you're going to see strong network effects. And then this is really important. It's just the way they built Hyperledger. It was very modular. So a lot of blockchains we've been talking about. There's several pieces. There's like the blockchain. There's the consensus mechanism. There's all these kind of things that are put together. And what Hyperledger did, which is smart, is they said, hey, like we know this is going to change very quickly. We know we have that enterprises are a very diverse group of folks and they have a bunch of different applications. We should make this so that you can mix and match parts very easily. And that's what they've done. And I think that's been a successful strategy. Hashgraph, for example, as a consensus mechanism, and you could sort of take that and just put it on top of Hyperledger if you want to. So there's interesting things you can do with it. The biggest con, I think, with Hyperledger is that it's less differentiated than other blockchains, public blockchains, because it just more closely resembles traditional databases, right? And this really is sort of the existential question for a lot of blockchain technology, distributed ledger technology, is like, do you need to use it versus a traditional database? And and there's all these sort of the crypto anarchy and all this other stuff. But if you're thinking about just particularly for enterprise, you're saying, does this make business sense? I think that's going to be a tough question. It's a tough question now. So, given it's so much closer to traditional databases than something like Bitcoin, Ethereum, whatever else, it's just a question they'll have to answer. Here are some others, which we're not going to spend a ton of time on. I mentioned Corda already. They're doing financial infrastructure, and they have a fair bit of momentum. They've been in space a long time. So they were one of the early entrants. Hedera Hashgraph is one that just came out just very recently, and they have what could be some pretty game-changing technology on the scalability side, getting up to 200. They had a press conference recently, and they said they got to 250,000 transactions per second. It's pretty mind-boggling, while still maintaining consensus in a distributed ledger, which is like that's been tough to do up to this point. They have a private version called Squirrels. That's permission. These guys are going to be at our conference in April that we're having at UTD, so we're excited to have them. Ripple and Stellar are two that are geared more towards payments. One, Ripple is permission, it's a private ledger. Stellar is sort of like a public version that's trying to achieve a somewhat similar use case. So these are just some of them. Again, if I forgot your favorite blockchain, I'm sorry, but these are some of the ones maybe you can find on. So I want to talk about something that I think is a pretty good application, given all the things we talked about, and something I'm pretty interested in, which is decentralized exchange. You remember what we talked about earlier, one of the sort of interesting things about blockchain when it came is that there was this new self-custody model, which, if you think about it, that's how things used to be, right? Back in the day before you had banks, like everything was self-custody. If you had a bunch of gold or something, you had to hold on to it, someone stole it from you, ownership was kind of the law in that time. And now with blockchain technology, what happened is that we had this huge migration towards technology, things became centralized like they are now, and now we're having things like Equifax hack and hundreds of other instances I'm sure you guys are familiar with. And so this new self-custody model is very interesting because it allows us to do business in a lot of the ways that we're used to doing without having to potentially give up custody or put our private information on an exchange where it can get hacked. So I think that's a super interesting use case. And just to explain what decentralized exchange is a little further. So in a centralized exchange model, right, I've got my assets, they're being held by somebody, and I sort of go through that gatekeeper trade. Pretty simple. Any brokerage, whatever you use, is going to do that. Decentralized exchange, it essentially provides an order book, but you hold the asset. And so you don't actually have to put your asset or your information into this intermediary to do a transaction. And there's live versions of decentralized exchanges that trade digital assets right now, and they're super interesting. So I think the opportunities to eliminate these bad intermediaries where bad could be a lot of things. It could be unethical. It could be that they're just not looking out for your best economic interest. It could be that they just don't maintain good order books. And I think it gives you, when you're talking in the context of digital assets at least, it gives you the ability to send anything anywhere without anyone who sent an international wire, maybe even just a regular wire, knows how that process is more expensive and kind of more cumbersome than it needs to be. And with this, you can send huge amounts of money or basically anything very cheaply and easily, which I think is interesting. And then finally, it potentially enables liquidity when there wasn't any by creating, if you think about how do marketplaces form, it's when there's enough opportunity to support a market. So there's sort of this minimum level of overhead required to run a market, right? Because you need to have paid professionals or set up technology infrastructure to facilitate the workbook. Well, you can think about decentralized exchange and blockchain more broadly as sort of lowering the required overhead for transacting in some cases. And so, think about some very liquid asset that is sort of expensive. It doesn't have good liquidity. On a decentralized exchange context, you sort of fractionalize it and create an order book because there's less required overhead. And so you can sort of bring liquidity with less money. And pretty tightly coupled with decentralized exchange, this idea of traditional tokenized assets. What which is really interesting because we've seen just how easy it is to, for example, send Bitcoin or Ether or some of these other digital assets. Well, what happens when we start traditionalizing these or tokenizing these traditional assets that we historically think were very slow-moving, illiquid things, and there's the potential you could inject a lot of these. And then another big exciting thing, I think, for maybe for the firm is that you can automate a lot of the reporting, tax, and legal work. Smart contracts for legal are one of the most exciting areas in space, in my opinion. So the ability to sort of like automate all these intermediaries and do it in a trusted way is really exciting. And layer on the fact that it can be self-custody as well is pretty interesting. And then the other thing is just an insanely huge market. There's just trillions of dollars of illiquid assets that are sitting around and potentially be tokenized. So this is actually a pretty big interest of mine. So if anyone's working on this or wants to, be happy to chat about it. So some things I wanted to sort of leave you with here. I know that things are often pretty rosy when you talk to people about blockchain. There's a lot of hype. What I try to do here is really focus on what the technology actually is and outline. Hopefully the takeaway here is that this is just another type of technology, another type of database technology. It's one way of doing business. It's certainly not the only way of doing it. And we should be, if we want it to succeed, we should be really cognizant of what the shortcomings are. So these are what I think the biggest challenges are for near to medium term, even longer term adoption for blockchain technology. And the number one thing is scalability. I think I've probably mentioned it 10 times now, which is being able to cost effectively and securely send a large number of transactions. Again, especially in the financial context, we are accustomed to being able to send as many arbitrary transactions as we want and not have to pay a lot for it. And this is sort of fundamentally an issue with enterprise adoption for blockchain. As mentioned, I think Hyperledger is solving this problem. I think there's a lot of other folks solving this problem, and it will ultimately get solved. But right now, it's a big issue. The second thing is developer scarcity, which is maybe not something that you would thought you would see on this list. But just in my personal experience, this has been a really big headwind for adoption in this space, particularly for enterprise people, because I think on average, more traditional enterprise folks are having a hard time recruiting top technical talent versus the Googles and the Facebooks and other people of the world. And I would also say is that these decentralized models give a lot of incentive to individual developers to kind of work on something. And so this has been something I've seen with people and companies who have tried to get markets around. Solving this problem has been really tough because the demand is growing much faster than the supply of labor. So something to keep in mind if you're an enterprise you're wanting to kind of specialize in this field, it's going to require a pretty significant amount of effort on that front. And then finally, the reality is that in most business cases, regular databases are probably sufficient, right? That's not to say that I think there'll be some really tremendous opportunities for blockchain. I think it'll transform parts of our internet infrastructure, but it's not going to just be a solve-all for every single business problem, right? In fact, there's a lot of companies and industries that just need to that are on sort of legacy infrastructure that just need to transition to better technical infrastructure and a traditional database, and they would get probably 85% of the benefit, right? So I think this is going to be a pretty big headwind for a lot of blockchain and distributed electric applications. Once we get past this hype phase of like, okay, this is great, but could I have done this with a traditional database? And do my customers really care, for example? That is a little more centralized, right? Have we been hacked? We have good security. So that's something to keep in mind. I did want to touch on I mentioned a couple times, we're having an event at UTD in April 18th and 19th. I've got some information on the next page, called the Emerging Technology Summit, and it's very timely for this discussion because it's probably 70–80% blockchain related. And like you guys, we sort of recognize at the university that this is an important problem. We want to be kind of forefront of it. So Don Tapscott's going to be our keynote speaker. For those who aren't familiar with Don, he's one of the leading kind of enterprise minds on the strategy space around blockchain. He wrote a book called The Blockchain Revolution. He runs the Blockchain Research Institute. So he's sort of specifically catered towards enterprise use for blockchain. So we're really excited to have him. Chandler over at the SEC, who has been involved in some recent regulatory action, which, if you've read the news, is a pretty interesting area in this space. So we're really excited to get his input on ICOs and other areas. Lee Barrett's the CTO at Hashgraph, which is that new technology I mentioned that's really exciting, that hopes to solve some of the scalability issues that we're seeing in the industry. Rafi Ghasanian is a expert in blockchain and has done patent work for a lot of enterprises, including Hyperledger and IBM. And so has really good insight on which enterprises and companies are filing for which patents and just what are the general trends in technology. And maybe some other folks here as well. And there's on the website we have, here's some more information. It's on the 18th and 19th. We have other speakers. So if you're interested, you can go to the website and get tickets there. I think we've been planning for months, and I think it's going to be a really exciting event. So we're excited to put it on and have some more enterprise partners come out and see it. You've got my background on a piece of paper, so no need to talk about me. Hopefully we can do some Q&A if we've got time.
We do.
Awesome.
Absolutely.
Yeah. Just for those of us who weren't as quick, could you explain proof of stake again?
I'm sorry, explain.
Proof of stake?
Oh yeah, sure. So proof of stake is just another, if you're familiar, so again, this is a consensus mechanism. So part of the challenge with these networks when you've got a distributed database is figuring out, what is the current state, and there needs to be a cost, if you will, to, because otherwise you can just spam the network, you can just change it kind of willy-nilly. And so, and this is high level, but proof of work, proof of stake kind of enable you to securely confirm consensus across the distributed network. And the only difference between proof of work and proof of stake is that proof of work uses computers and energy to solve computational problems. Proof of stake, you put your capital in, and it's at-risk capital. So if you do something bad in the network, you're going to lose your capital. So you're incentivized to do the right thing, and you also have costs associated with confirming transactions on the network. So the only difference is sort of, and really, if you want to think about the first principles, it's both capital. You're either paying for equipment and electricity, or you're just paying, right? So that's really the difference. And so the idea is that it can mitigate some of the issues around, for example, using all the world's energy to mine Bitcoin or mine all these proof of work. And there's more technical reasons for it as well. What I'll say is that this is not, this is a highly technical issue that's debated by some of the smartest people in the world, and it's not clear, if one's better than the other. But there's just some trade-offs. Yeah.
Thank you for coming today.
Yeah.
This is by far the best blockchain presentation I've seen today.
Oh,
so
appreciate
thank you
that.
for
Yeah.
that. I've got two questions. One is with a copy of the database being on every device that's using the network, how much data does that take up? How much storage space does that take up?
I'm not sure what the sort of total storage space is, but just one thing to clarify. So the answer is I'm not sure the total data requirements. I mean, it could get massively large, but it's not going to be, if you think about it, it won't be any bigger than it needs to be, right? So that data will still be stored at the same size in a centralized database. It will be maybe done in a more efficient way. So you're losing efficiency, but you're gaining some of these other attributes. But to participate in the network, you don't need to be running a full node. You don't have to be having a copy of the blockchain. You can interact with someone who is. So, like for example, there's like applications right now on your phone, for example, either send Bitcoin or send Ether or do all these things, and you're not actually running a node on your phone that's sort of like keeping a database of blockchain, which is pretty large. I can't remember how big it is, but it would take up your computer. It would take up a decent chunk of your computer. You would interact with a node that sort of is, and like you don't have to go through them. And so that's important because you don't want too much of that, because if too many people are using like the same node, for example, it's centralized. So there's always this sort of like trade-off between like, efficiency and usability versus being too centralized.
If I could have one more.
Yeah, go for it.
Banking, how, besides the disrupting potentially the transaction business that banks do, what other major impacts should banks be thinking about?
Yeah, I mean, I think the risk with banking, and you can really abstract it to, the way I try to think about it is more from like first principles, which is like, this is a tool to disrupt intermediaries who are taking fat margins on just being an intermediary, right?
That's not bad.
Well, I think that's the sort of opportunity for banks, is that there's a lot of service models in banks, a lot that banks charge for, where they're just sort of eliminating counterparty risk, or they're providing sort of technology as a service, or they're providing custody as a service, for example. And I think the opportunity is to automate a lot of those services and effectively compress the margins on them, which is good for, I think it's good for the end users. It's good, and it's good for a lot of business applications who rely on this infrastructure. But sort of custody as a service, I think, is the thing. Custody or intermediary as a service, depending on what the intermediary service is what's really kind of in the crosshairs for banking. In addition to things like literally being the form of payment, like in Ripple's case, they're trying to create like an actual payment kind of infrastructure where Ripple is the actual payment. So that's the other thing.
Thank you.
Yeah. Oh, sorry, I'll let you take it all.
Steve, let's do Steve.
So you talked about some of the challenges being efficiency of the current centralized database model. Are there some criteria, high-level decisioning that I would look at to make blockchain or DLT more attractive versus centralized?
Yeah, I think the answer is that it's just a really tough question, and it's what a lot of enterprises are grappling with, and they're creating proof of concepts. I don't know that there's not like a specific KPI that you can look at. Some of the things I would look at is that if you're just in a system that sort of continually breaks down, or you're getting bad economics because of some intermediary, that seems like a pretty good use case. And that's in the enterprise kind of side. Obviously, there's stuff outside the enterprise where things like governments like censoring data, whatever, where you can just wholesale prevent those things. But I think if you look at some of the proof of concepts that are being worked on now, particularly around supply chain, stuff like provenance of the supply chain, like if I've got this massive supply chain and this piece of equipment, this widget moves through like 100 different things, like, and it gets lost. Like, at what point does it get lost, right? And part of the problem there is that you're having, each company in that process has this like different disparate infrastructure, right? And because we don't trust each other, we need to kind of have like our own. And I think when you have that on a blockchain, it enables you to like track it more. So that's a potential use case. So to answer your question, I think you've got to have like a real business problem where you're saying that, hey, I've got a traditional database that works great. Like from a transactional standpoint, there's some other intermediary issue or some problem that I'm trying to solve that where you just keep running into issues. That's where I'm saying a lot of the kind of proof of concepts right now. Yeah. Sorry.
Other than the compression of transaction fees, do you see any industries, services, platforms, or companies in particular that might be vulnerable to obsolescence as blockchain evolves?
Yeah. I mean, I think a lot of these like intermediary services people, I think anyone who's sort of providing infrastructure as a service or custody as a service, I think is potentially a risk. Because again, what they're essentially providing is trust. And that's what these models are designed to disintermediate. It's trust where before, if I needed to send something, if I needed to transfer assets, if I needed to do business, I had to rely on this person to maybe verify that transaction was correct, or verify that if Sally was sending Bob, that Sally actually had something in her account, right? And now you just don't need them anymore to perform that function. And so if you can address the scalability concerns while still performing that function using blockchain, then there's really no reason to use like that essential intermediary, because it comes with all the issues, right, we discussed. So I think banking is, certainly parts of banking are kind of the crosshairs versus a supply chain. It's really tough to pick an individual industry because, centralized trust structures exist in every industry, right? So I think it's more about focusing on what parts of the business, like, supply chain, payments, custody. I think that's kind of a better way to look at it. And another one is smart contracts for legal. I think a lot of legal work will be automated. And there's Clause.io, which is going to be at our conference. They're working on this on Hyperledger, specific to that problem. They're making sort of infrastructure to replace a lot of legal logic. And of course, you still have attorneys, but it just will replace a lot of the lower level stuff.
The question regarding ICO is the hot, sexy term of Wall Street. Everybody's fascinated by ICOs, companies, etc. Can you break down how the ICO actually functions and how that actual real currency drops back down into the real world of the bank? That's a part of the connect the ICO digital world with the actual how the corporation will get that cash into the funds.
Yeah, I actually have for those interested in this topic. I sort of intentionally didn't. Okay, lost there. Intentionally didn't talk about tokens, so that's sort of a different topic. But the way that it connects, the answer, candidly, is that tokens, the sort of truly decentralized network, don't connect to the traditional infrastructure. So I think it was designed to not connect. In cases where you have Ripple or others who are making tokens in these networks, what you're really doing is pairing them into a traditional database or making them look more like a traditional database before. So I think the question is, if if I'm understanding it, is how does a token sort of fit in with an actual business?
Like if I did a $10 million ICO,
Right.
how do I move that 10 million to my bank account to run my business?
You can't, unless Bank of America has unless Bank of America has a way to accept custody of those assets. And to do that, they would have to. And the reason they haven't done that is because of all these different sort of regulations.
Didn't you tell me that JP Morgan is working on this? Isn't that it's been billions of dollars? if I'm not mistaken.
Tens, in fact.
Yeah.
So and we can talk offline, but yeah, there was it's an iteration, if you will. It doesn't look like this. The same problems still exist in the. He mentioned it when everyone needs to have a node to run that process. Right now, if you try and sell your Bitcoin when 10 million other people are, because CNBC is saying it's tanking and everyone goes to sell it, you may sell it today or 3 days from now. It depends on the processing. You don't know who's buying, who's selling, who's transacting. So that's one of the things that we're trying to fix, if you will. But it's not a coin. It's the underlying technology, as he explained it, that really creates the synergy where you can have an ACH transfer into the T+3 the same day.
Right. So to answer your question directly, you would have to inherit the infrastructure. So for example, if I wanted to see in Bitcoin, and people have done this, there's a company called Coinbase that has a centralized infrastructure for trading tokens, and they literally take custody of the assets, and they have a license to do so. They're regulated like a regular company. So you just have to create a centralized database infrastructure, and there's something called a multi-sig wallet that lets you do that. But it couldn't exist on traditional infrastructure. You need certain infrastructure to do that.
Thank you so much to everybody. We always try to put it off right at 9 o'clock so you can get out and get where you need to for the day. Thank you so much for attending. Thank you so much for speaking.